Good evening, dear children. I hope your NEET preparations are going at its full pace. So, all of you are revising the topics on a regular basis, and your teachers have been telling you how to prepare effectively for the NEET examination. And most importantly, in these few days remaining, NCERT textbook should be your Bible. So, everybody must be thorough with all the contents given in the NCERT textbook. And once you have finished that and you are so confident that you have covered each and every section in NCERT, then only go for any kind of extra reference. So as far as NEET exam is concerned, you must be thorough with NCERT. So today we are going to discuss a module, a chapter from 11th standard chemistry. And that is some basic concepts of chemistry. So from this chapter, frequently there are so many numericals asked, and we can pinpoint and say that these are the important areas where the questions are frequently asked. So you will definitely have questions related to mole concept, you will have questions related to stoichiometry, you will have questions related to empirical formula and mass percentage analysis. So today we will be having a quick recap and walk through the most important questions and topics from this chapter. I hope I am audible to everyone. Right. So without wasting much time, let's go to the first question. Equal masses of hydrogen, oxygen and methane have been taken in a container of volume V at temperature 27 degrees Celsius in identical conditions. The ratio of the volumes of the gases H2O2, methane would be. So here in this question you can see that there are three gases given. One is hydrogen, one is oxygen, and the other one is methane, which is CH4. Now they said equal masses of these gases have been taken in a container of volume V and temperature 27 degrees Celsius. So we can assume that all of these gases are having the same weight, because it's already mentioned it is equal mass. Now these gases are all under a constant volume V and a constant temperature, that is 27 degrees Celsius. And the question is, the ratio of the volume of the gases H2O2 and methane would be. See, I believe you all remember Avogadro's law. What does Avogadro's law state? It states that equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. So we can apply that logic in this question. So here, since all the conditions are same for the gas, we can say that the volume is directly proportional to number of moles. So if you want to find out what is the ratio of the volumes of the gases, you can simply find out what is the ratio of the number of moles, because all gases under similar conditions of temperature and pressure contains equal number of molecules or moles. So if we have to find out what is the number of moles of any substance, number of moles of any substance is equal to the given mass divided by the molar mass. The given mass divided by the molar mass. So if you apply this formula in this case, hydrogen, the number of moles of hydrogen is equal to the given mass, let's take it as W, because all the gases are having the same mass, divided by the molecular mass of hydrogen is 2. The number of moles of oxygen is again the given mass of oxygen divided by the molecular mass of oxygen. So this is O2 molecule, so the mass is 32. And the number of moles of methane is equal to the given mass divided by the molar mass of methane. What is the molar mass of methane? What is the molar mass of methane? You can see that methane has a carbon atom which is having 12 units mass and 4 hydrogen atom each having 1 unit mass. So total mass is 16. So W divided by 16. So we have seen the number of moles of each of these gases. So if you take this ratio, this will be the same ratio for the volumes as well, because volume is directly proportional to number of moles. So number of moles of hydrogen is to number of moles of oxygen is to number of moles of methane. What are we getting? The ratio is W by 2 is to W by 32 is to W by 16. So the simple ratio is 1 by 2 is to 1 by 32 is to 1 by 16. So what will be the whole number ratio? We can say 32 by 2, 16 is to 1 is to 2. So this will be the ratio of each of these gases respectively. The number of moles of hydrogen is to number of moles of oxygen is to number of moles of methane is going to be 16 is to 1 is to 2. So hope everyone have understood this numerical. Right. So the right option is option C. So here keep in mind we have applied Avogadro's law. Similar equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. That is the logic that we are applying. Right. Look at the next question. What volume of oxygen gas measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas measured under the same conditions? So the question is, we need to find what is the volume of oxygen gas which is measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas. So here we are looking at combustion of propane, correct? So let us try to write the formula of combustion of propane. C3H8, that is propane, and if it undergoes combustion, that means it is going to react with oxygen and you are going to get what? Carbon dioxide and water. Because you have already studied that when we burn hydrocarbons, the products are carbon dioxide, water and energy. Now we need to balance this equation, because you know that every chemical equation must follow the law of conservation of mass, and in order to satisfy the law of conservation of mass, we will balance the chemical equation by putting the suitable stoichiometric coefficients, because that makes a big difference. The stoichiometric coefficients are those numbers which we use to adjust the equation so as to balance it. So here you can see that there is 3 carbon on the left side, so we will multiply here with 3. There are 8 hydrogens on the left side, so here we will multiply with 4. So oxygen, carbon and hydrogen are balanced. Now what is not balanced here? You can see there are 2 oxygen on the left, but here how many are there? 3 into 2, 6 oxygen plus 4 oxygen. So we have total 10 oxygen on the right side. So how do you balance it? We get 5O2. 5O2. Now we get a clarity. What is the question now? They asked what volume of oxygen gas. So if we have to look in terms of the volume, it is very evident that 1 liter of propane is requiring 5 liter of oxygen to form 3 liter of carbon dioxide and 4 liter of water. Correct? So the question was, how much volume of oxygen is required to burn completely 1 liter of propane gas? So as per the stoichiometry, 1 liter requires 5 liter. Is that clear to everyone? Okay, good Hafiz. Now Let's look at the next question. Which one of the following has maximum number of atoms? This was a 2020 NEET question, and similar kind of questions have been asked continuously in all the years. Calculating the number of atoms, or which one has least atoms, which one has more molecules, which one has least molecules, such kind of questions are always regularly asked in NEET examination. So in this case, you can see that all the options are having same mass of the substances, correct? Same mass of the substances. So we have 1 gram of silver, we have 1 gram of magnesium, 1 gram of oxygen, 1 gram of lithium. So here the mass is same, correct? Now everybody know that the number of moles formula is W by M, that is given weight by molar mass. And the number of moles can also be written as the number of molecules or the atoms divided by the Avogadro number. So if we look into this formula, we can combine it and write it as W by M is going to be N divided by Na. Or in short, N is equal to W by M into Na. I believe all these letters, what is represented here, are clear to everyone. What is capital N? Capital N is the number of particles. What is W? W is the given mass. How much mass of the substance is given. What is M? M is the molar mass of the respective substances. What is Na? Na is Avogadro number. So without even calculating, you can directly answer this question, right? How? You look here. Most number of particles will be present for that substance which has least molecular weight. Do you agree with me? Because if weight is constant, the given mass is constant, the number of particles will be more for the substance which has least molecular weight, correct? If you simply use that logic, you can easily answer this question. You see, in case of silver, 1 gram of silver, if you want to find the number of particles, we will be writing it as 1 divided by the atomic mass of silver is 108 into Avogadro number. Then 1 gram of magnesium, that is the next one. 1 gram of magnesium will have number of particles equal to 1 divided by 24 into Avogadro number. Then we have 1 gram of oxygen molecule. Here you need to be careful, because in case of oxygen molecule, you know that there will be 1 mole of oxygen molecule will have Avogadro number of molecules of oxygen, or 2 times Avogadro number of atoms of oxygen, because oxygen is not a monoatomic species, it is a diatomic species, correct? So here the total number of particles will be 1 divided by 32 into Avogadro number into 2. That many number of atoms will be there. And 1 gram of lithium, the number of particles will be 1 divided by 7 into Avogadro number. So you don't have to calculate it here, because easily you can select the answer, because I told you that lower the molecular weight, that will have more number of particles. So in all these things, you can see that the denominator, then the molecular weight is the lowest for lithium. So that will have the most number of particles. So 1 gram of lithium will have most number of particles. Is that clear to everyone? Yes, Hafiz, very good. 1 gram of lithium will have most number of particles. So I believe this kind of questions, when you are dealing, make sure you are comparing it in the same units. In this question it is more easy, because everything is given in the mass, 1 gram. But sometimes they will give different values, like some will be given in volume, some will be given in number of moles, some will be given in another option will be given in mass. So you have to unify it and then do a fair comparison. Clear? Right. Yeah, look at the next question. This is a similar question which I have just told you. In which case is the number of molecules of water maximum? The number of molecules of water maximum. Here you see Option A is 18 ml of water. Option B is 0.18 gram of water. Option C is 0.00224 liter of water. And option D is 10 to the power minus 3 mole of water. So here if you want to compare, bring everything into the same unit. So here they asked which has maximum number of molecules. So we can express everything in everything in the terms of number of molecules. So look here. First of all, option A, what does it say? 18 ml of water. 18 ml of water. You guys know that water is a substance which has its density value unity, isn't it? What is the density of water? 1 gram per centimeter cube, or 1 gram per ml. What does that mean? 1 ml of water is equivalent to 1 gram. So 18 ml of water is as same as 18 gram of water. Correct? And if I have to find the number of particles in that, how do I do it? 18 gram divided by the molar mass of water is 18 into Avogadro number. So this many particles will be there. So that will be equal to Avogadro number itself. Correct? Okay. Option B, 0.18 gram of water. 0.18 gram of water. In that, how do I find the number of particles? It will be equal to the mass of water given divided by molar mass into Avogadro number. Correct? So 0.18 divided by 18. That will be 10 to the power minus 2 times Avogadro number. So option A has Avogadro number. Option B has 10 raised to minus 2 into Avogadro number. Now option C, 0.00224 liter of water vapor at 1 atm and 273 Kelvin. This is very important. You guys know that there is something called molar volume. Molar volume. What is molar volume? The volume occupied by 1 mole of any gas at STP. So here you see the conditions given. 1 atm, 273 Kelvin. This is called standard temperature and pressure, STP. So at STP, 1 mole of any gas will be occupying a volume of 22.4 liters. So this is something that you need to always remember. 1 mole of any gas occupying a volume of 22.4 liter at STP. And what do we call that volume as? This volume is known as molar volume. Molar volume. Molar volume. So whatever is the number of moles or whatever is the volume occupied by a gas, if you make that volume to 22.4 liter, that will be equivalent to 1 mole of that gas, or that will be equivalent to the molar mass of that gas. The quantity will be as same as the molar mass of the gas. So this is a very, very, very important concept. You should not forget it. This is molar volume. So in case of 0.00224 liter of water vapor, how many molecules will be there? See, in simple words I can write 1 mole of a gas or 1 mole of water if I take, its volume will be 22.4 liter, correct, at STP, and that will have Avogadro number of water molecules. Yes or no? That will have Avogadro number of water molecules. So 22.4 liter is what is known as 1 mole or Avogadro number. So you need to find out how many molecules will be there in 0.00224 liter. Correct? So we can write like this. 22.4 liter will have Avogadro number. You agree? So 0.00224, I can write it as 22.4 into 10 to the power minus 4 liter will have how much? That is the question. So how much will that be? It will be equal to Avogadro number divided by 22.4 into 22.4 into 10 raised to minus 4. So how many molecules will be there? That will be as same as Avogadro number into 10 raised to minus 4. So we got the third value also. In the third option, how many molecules are there? That also we got. Now finally we have one more option remaining. Let's do that as well. 10 raised to minus 3 mole of water. 10 raised to minus 3 mole of water will have how many molecules? It will have 10 raised to minus 3 into Avogadro number. So you see here, we have figured out everything in the number of molecule state. Option A contain Avogadro number, option B contain 10 raised to minus 2, option C contain Avogadro number into 10 raised to minus 4, and option D contain Avogadro number into 10 raised to minus 3. What is the question? In which case you have more number of molecules? So what will be the answer? Where do you have more molecules? Yes. Option A. 18 ml of water will contain 6.022 into 10 raised to 23 molecules of water. Is it clear to everyone? So here each of the options were given in different units. So we brought it into the same value, that is we just calculated in each of the case how many molecules are there, and then we did a fair comparison. See, when you practice these kind of questions, you get to know by simply looking at the option itself, you will be able to answer it. But for that you need to do as many questions as possible. The major difference between the board examination and NEET examination is, you need to be really fast. You need to manage your time. So for this, you can work out as many questions as possible. Even when you are doing these questions at home, when you are practicing questions, try to put a timer and see how much time you are spending on each question. And that makes a big difference in your score. Trust me. So let's go to the next question. Okay. Suppose the elements X and Y combine to form two compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram, the atomic weights of X and Y are, see, it was a 2016 question and a very important question as well. Here, in this case, they have given two elements X and Y, and the formula of the compounds is, the first compound is forming XY2 and the second compound is forming X3Y2. So here two elements X and Y are forming two different compounds. Now the question is, when 0.1 mole of XY2, 0.1 mole of XY2, its weight is 10 gram, and 0.05 mole of XY2, its weight is 9 gram. Then what are the atomic weights of X and Y? That is the question. See, you can approach this question in two different ways. Okay. See, first one, in the case of XY2, you know that in this compound, X and Y are the elements, right? So the whole molecular weight of that compound will be the sum of the atomic masses of X and the 2Y, correct? Similarly, the whole molecular weight of X3Y2 will be same as the atomic masses of the 3X and the 2Y added together, correct? So let us imagine, let us take X is the molar mass of the element capital X, and Y, small y, is the molar mass of capital Y. So in this case, we can say that the total molar mass of XY2, I can write like this. XY2, its total molar mass can be written as X plus 2y. Do you agree with me? X plus 2y. This will be the total molecular weight of the compound XY2. Correct? So they said 0.1 mole of this compound weighs 10 gram. 0.1 mole of this compound weighs 10 gram. So see here, if I have to look into this formula, that is 0.1 mole of this compound has a mass of 10 gram. So imagine what will be the mass of 1 mole of this compound. What will be the mass of 1 mole of this compound? 0.1 mole is 10 gram. So 1 mole will be what? It will be equivalent to 100 gram. And do you agree with me that 100 gram will be the molar mass of XY2? Yes or no? 100 gram will be the molar mass of XY2. Similarly, look here. In case of X3Y2, let's find out how much is the mass of 1 mole of X3Y2. 0.05 mole is 9 gram. So 1 mole will have how much mass? 9 divided by 0.05, isn't it? That will be equal to 180 gram. So in front of you, you can clearly see that molecular weight of XY2 is 100 gram and molecular weight of X3Y2 is 180 gram. Okay. Now there is an easy trick here. Look here. The formula is XY2 in this case and X3Y2 in this case. What is the difference in these two formulas? This compound has 1x, whereas this compound has 2x. Yes or no? Yes. So the only difference between this formula and this formula is a difference in 2x. And how much is the mass difference coming in that? 100 is the mass of the first compound and 180 is the mass of the second compound, correct? The difference is 80, and that 80 is because of 2x, correct? So 2x is contributing 80. So what will be the mass of 1x? It will be 80 divided by 2, and that will be 40. Did you understand that? So you easily found out what is the atomic mass of X, the first element in that formula. And look at the options here. There is only one option where X has an atomic mass of 40. Is that clear? X has the atomic mass of 40. There is only one option. And Y is going to have atomic mass 30. So in this question, what did I do in this step? This part is very important. Look here, they said 0.1 mole of XY2. That compound has a mass of 10 gram. So what did I do? I just escalated that value equivalent to 1 mole. See, 0.1 into 10. That is 1 mole, right? So how much will be its mass? Into 10, which will be 100. That's how I got 100. So 1 mole of any compound's mass is what is called as molecular mass. So that's how I got 100. And the same thing, the same logic you apply here. 0.05 mole has a mass of 9 gram. So I found out 1 mole has how much? 9 divided by 0.05. That will be 180. Did you get it? This is 100 and 180, and here I checked XY2 is the formula of the first compound and X3Y2 is the formula of the second compound, and I just found out that the mass difference between this compound and this compound is just 80. And what is the difference in their formula? It has, the second compound has 2 additional X. Just because of having 2 additional X, how much is its mass difference from the first compound? First compound is 100, second compound is 180. So the difference in mass is 80. So 2X is contributing 80. So 1X will have a mass of 40. Is that clear to everyone? And we can write the same thing here also. X plus 2y is going to be 100. And for the second compound X3Y2, we can write 3x plus 2y is going to be 180. Even when you write like this and solve this equation, you will get the values. I'll show you that as well. Check out this first equation and the second equation. Okay, let me subtract 2 minus 1. What will I get? 3x minus x is 2x. Then 2y minus 2y is 0. That is equal to 80, or x is equal to 40. So once you get x, you can substitute in the first equation to get y. What will be the value of y? X is 40. 40 plus 2y is 100. So 2y is equal to 100 minus 40, or 2y is equal to 60, or y is equal to 30. Got it? Sarim, is it clear? Right. So this is all just based on the stoichiometry of the compound. How much of the atoms, what is the molar mass, and then we solve these equations based on that. See, this method is more easy. You can just convert it into equivalent numbers in 1 mole and then see the difference, because in both the compounds y is the same. So in that way you can solve this. Okay. Next question. Which has the maximum number of molecules among the following? Maximum number of molecules among the following. See, 44 gram of carbon dioxide. See, I told you already the formula to find the number of molecules. What is the formula? Given weight by molar weight into Avogadro number. Correct? So in case of 44 gram of carbon dioxide, what is the given weight? 44. What is the molecular weight of carbon dioxide? Carbon dioxide, carbon is 12 and oxygen is 32. 12 plus 32 is 44. So divided by 44 into Na. So 44 gram of carbon dioxide will have Avogadro number. Then option B, 48 gram of ozone. 48 gram of ozone. How many molecules will be there in that? 48 divided by ozone is 3 oxygen atoms. So molecular weight is 3 into 16, which is again 48 into Avogadro number. That is also equal to 1 mole or Avogadro number. Then 8 gram of hydrogen. 8 gram of hydrogen. N is equal to 8 divided by molecular weight of hydrogen is 2 into Avogadro number. That will be 4 times Avogadro number. And option D is 64 gram of sulfur dioxide. Number of molecules is going to be 64 divided by sulfur is 32. 32 plus 2 oxygen is again 32. That will be 64 times Avogadro number. Again we are getting Avogadro number. So easily you can see that the answer is 8 gram of hydrogen, which contain more number of molecules. Again, the same logic we are applying here. Like, smaller molecular weight substances will have more number of molecules. Yes, majority of you have answered it. Yeah, very good. Option C. Let's look at another question. The number of atoms in 0.1 mole of a triatomic gas is. Number of atoms in 0.1 mole of a triatomic gas. Very easy question. Look here. Triatomic gas. Let's take that gas as X3. Triatomic means there are 3 atoms in that gas. Correct? X3. So you tell me 1 mole of that gas will have Avogadro number of molecules. Do you agree? Avogadro number of molecules. Or I can also write 1 mole of that gas is going to have 3 times Avogadro number of atoms. Because X3 is a molecule. So 1 mole of that molecule will contain 6.022 into 10 raised to 23 molecules. But in terms of atoms, how do I express? You know that every molecule of that triatomic gas will have 3 atoms total. Correct? So 3 times Avogadro number. And they asked 0.1 mole will have how much? 0.1 mole will have how much? 0.1 mole will have 3 into Avogadro number is 6.022 into 10 raised to 23 into 0.1. 0.1 is 10 raised to minus 1. So that will be equal to 18.066 into 10 raised to 22, or I can write 1.8066 into 10 raised to 23 atoms. 1.8066 into 10 raised to 23 atoms. So we have that option here. Clear? Right. So I believe all the steps are clear for everyone. Next one. The number of atoms in 4.25 gram of ammonia is approximately, come on, quick. The number of atoms in 4.25 gram of ammonia is approximately. See, they are asking again to find out the number of atoms. So, you have to instantly get those connections in your brain. You have to bring it about ammonia. Think about ammonia. One ammonia molecule, NH3, contain 4 atoms. So, one mole of ammonia will contain Avogadro number of molecules of ammonia. Correct? We can say 1 mole of ammonia is equivalent to how many molecules? 6.022 into 10 raised to 23 molecules. Now you tell me, 1 mole of ammonia, isn't that same as, or can we express that 1 mole of ammonia in terms of mass? Yes, of course, because 1 mole of ammonia will be similar to ammonia, nitrogen is 14 and hydrogen 3 are there. So 14 plus 3 is 17 gram. 17 gram is going to have 6.022 into 10 raised to 23 molecules of ammonia. Correct? Molecules of ammonia. In terms of atoms, how much will that be? Every ammonia contains 4 atoms. So I can write 4 into 6.022 into 10 raised to 23 atoms will be there in 17 gram or 1 mole. But what was the weight given here in the question? 4.25. 4.25. So let's find out. 17 gram contain this much. So 1 gram contain how much? 4 into 6.022 into 10 raised to 23 divided by 17. Therefore, 4.25 will contain 4 into 6.022 into 10 raised to 23 divided by 17 into 4.25. Correct? All of you understood this expression? See, this sequence of steps what I have written here, it should go through your mind in a fraction of a second. 17 gram contain this much, so 4.25 will contain how much? Like this, instantly it should go, and the last calculation only should be done by you in that rough work. Is it clear? If you keep writing steps like this, you won't get time. Now you see 4 into 4.25 is 17 again, right? So 17 and 17 gets cancelled, so it will be equal to Avogadro number itself. That many atoms will be there, right? And in the options you can clearly see that Avogadro number is not given as accurate value, it is just approximated and taken as 6 into 10 raised to 23. Did you understand this question? Is this question clear to everyone? Okay. Now look at the next question. An organic compound contains carbon, hydrogen and oxygen. Its elemental analysis gave carbon 38.71%, hydrogen 9.67%, and obviously the remaining will be oxygen. The question is, empirical formula of the compound would be, you guys know what is empirical formula. What is empirical formula? The simple whole number ratio of the atoms present in a compound is what is expressed in empirical formula. For example, if I consider glucose, just for an example, if I take glucose, you know that glucose is represented as C6H12O6, correct? This is the molecular formula, which means it is indicating the exact number of atoms present in glucose. But I can also write this in a empirical format as CH2O, because the simplest ratio of atoms present in glucose is 1:2:1. So this formula is called as molecular formula, which indicates the exact number of atoms, and this formula is known as empirical formula, which indicates the simple whole number ratios, the simple ratios of each atom present in a compound. Is that clear? Now, here the question is, we need to find the empirical formula of the compound from these values. See, again, you can do it in two different ways. One is the normal empirical mass determination. You know, carbon, hydrogen, oxygen, all its percentages are given. You just need to find out what is the simple ratio of each of them. So if I take, in case of carbon, what is the percentage mass given? 38.71%. So let me express that in grams. In 100 gram, 38.71. Hydrogen is given as 9.67. So 9.67 plus 38.71, that minus 100 will be the amount of oxygen present. So it will be 51.62. And then I want to find the number of moles of each of the element. What do? I will divide the mass of each element by its atomic masses. So carbon's atomic mass is 12, hydrogen's atomic mass is 1, and oxygen's atomic mass is 16. So if I take an approximate figure, 38.71 divided by 12, it is close to 3. 9.67 by 1, it will be close to 9. 51.62 is again 3. So what is the simple ratio you are getting here? 1:3:1. And directly we can write the formula will be C1H3O1. Now, this is a little bit longer method. If you want to save time, you have one more way. All the empirical formula are given in the options, correct? So you just see in which option do you have carbon's percentage 38.71. So you see the way how you calculate that is, just look at CHO. In CHO, there is one carbon, one hydrogen, one oxygen, correct? So if the whole compound's empirical mass is taken, it will be 12 plus 1 plus 16, correct? That will be 29. Now in that, 12 gram is carbon. So 12 by 29 into 100, how much is that? Similarly, here CH4O, so 12 plus 4 plus 16. Like this, you can look into the formula and also find out in which case carbon's percentage is coming as 38.71. So that way also you can solve this question. So whichever you are finding convenient, you can go with that. Is it clear to everyone? So CH3O is the answer. If two elements are there, like hydrocarbons are given and this question is asked, you can easily solve it. As I said, like just find the percentage of carbon, in which case it is coming equivalent to the given percentage. Is that clear to all? Right. Next one. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's processes. What is Haber's process? See, specifically why did I put this question is to make you understand a very, very important fact. A very important fact about the NEET examination. See, you are studying lots of chapters in physics, lots of chapters in chemistry and bio. See, many a times the questions asked in NEET is not a single question asked in NEET is not from a particular chapter. You might have to have the knowledge of different chapters altogether to answer maybe one question. So these interlinked questions are very important. For example, you might be well versed in stoichiometry. Like you know that this moles will react to give this moles to give this moles of product. But you know, what if you don't know what is Haber's process, which is there in P block elements, where you study the preparation of ammonia. So if you have forgotten that reaction, this is just as an example I am telling you, you might get such kind of questions where the different chapter related questions are interlinked and a question is asked. So you might need to have the knowledge of 3 or 4 chapters together to answer that single question. See, Haber's process is an industrial process for the manufacture of ammonia from nitrogen and hydrogen. So nitrogen combined with hydrogen in presence of a catalyst to form ammonia. This is what is Haber's process. So look into this equation. This is not a balanced equation, so we can balance it. N2 plus 3H2 gives 2NH3. This is the complete balanced equation. So once you get this, you can easily answer this question. The question is, number of moles of hydrogen required to produce 20 mole of ammonia. So just extract the information which you need for this question. They are asking how many moles of hydrogen is required for 20 moles of ammonia. So you will directly write the stoichiometry. 3 mole hydrogen is needed for 2 mole ammonia. So for making 20 mole, how much you need? You need 30 mole. Correct? And you can easily find the answer. So that's the competitiveness which is expected from students. It's not like, they are going to ask very hard out of syllabus questions. All will be questions related to the syllabus only, but it will be a little bit twisted and messed up, like having the content or the concepts from different chapters. The same is applicable in case of biology as well. Okay, look at the next question. The density of 2 molar aqueous solution of NaOH is 1.28 gram per centimeter cube. The molality of the solution is, given the molar mass of NaOH is 40. This should be easy. This is a direct NCERT related question. So here what they are asking is the molality. You guys know the formula of molality. What is molality? Molality small m is equal to weight, number of moles of the solute dissolved per kilogram of the solvent. Correct? Per kilogram of the solvent. This is the expression for molality. So here the question is, the density of the solution is given 1.28 gram per centimeter cube. And the molarity of the solution is also given, which is 2 molar. What is the meaning of 2 molar? 2 molar means 2 moles per liter. 2 moles per liter. That is molarity. And molecular mass of the solute is also given 40 gram per mole. Okay. So in order to find molality, you need the number of moles. Number of moles is already here. In 1 liter, 2 moles are there. Divided by, you need to find the weight of the solvent, but you don't know what is the weight of the pure solvent, but you can find that. How we know that? Weight of the solution is equal to weight of the solute plus weight of the solvent. Now weight of the solution, that also we don't know. You see here they said density is 1.28 gram per centimeter cube. What does that mean? 1.28 gram is present in every ml, or 1280 gram is present in 1 liter, because in 1000 ml how much is present? That is 1280. So what 1280 gram is the mass of the solution, right? 1280 gram is the mass of the solution considering 1 liter solution. And weight of the solute, that you can easily find out because it says 2 molar NaOH. 2 molar NaOH. Number of moles of NaOH is how much? 2 mole. So you know that number of moles is equal to weight divided by molar mass. So weight of the solute is equal to what? Number of moles into molar mass. That will be 2 into 40 is the molar mass. So 80 gram per mole. So you got already the weight of the solution. You got already the weight of the solute. Now all you need is the weight of the solvent, which you can easily find out. So what is the weight of the solvent? It will be 1280 minus 80. That will be 1200 gram. This is all you need for calculating molality. 2 mole is the number of moles divided by what is the weight of the solvent? Weight of the pure solvent is 1200 gram or 1.2 kilogram. Is that clear to everyone? Yes? So that will be close to 1.67 moles per kg. 1.67 moles per kg or molal. So this is the molarity of the solution. Is this clear to everyone? Right. Let's look into the next question. What is the mass of the precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% NaCl solution? So you need to find what is the mass of the precipitate formed when you mix two solutions. What are the solutions that we are mixing? Read the question again. We are mixing AgNO3, silver nitrate, mixed with NaCl. And what will you get? AgCl plus NaNO3. This is a double displacement reaction and you get the precipitate of AgCl. That is what is happening here. So they are asking what is the mass of the precipitate formed. Here you see this equation is balanced already, right? And the stoichiometry is like 1 mole of this reacts with 1 mole of this to form 1 mole of this and 1 mole of this. So if you have to find the mass of AgCl formed, you need to see how many moles of AgNO3 and NaCl is reacting. So they said 50 ml of 16.9% solution of AgNO3. What do you mean by 16.9% AgNO3? It means 16.9 gram AgNO3 is there in 100 ml of the solution. So tell me, the volume that they have taken for mixing is 50 ml. So how much will be there in 50 ml? Half of that, correct? So 16.9, half of that will be 8.45 gram. So you got how much is the mass of AgNO3 going to react. Then similarly you apply the same logic for NaCl. What did they say? 5.8 percentage of NaCl. So 5.8% NaCl means what? 5.8 gram NaCl in 100 ml. So similarly what we did before, find out in 50 ml how much will be there. Half of that, 2.9 gram. So we got the masses of each of these substances, correct? Let's find out the number of moles of each of them reacting. So how do I find the number of moles? You can do that easily here. Number of moles of AgNO3 will be, how much is the mass of AgNO3? 8.45 divided by, you need to find the molecular weight of AgNO3. That is already given here. You see different molecular weights values are given here. So AgNO3. For AgNO3, the total molecular weight will be Ag is 107.8 plus 1 nitrogen is 14, then 3 oxygen means 48, correct? 169.8 is the molecular weight of AgNO3. 169.8. So that will be the number of moles of AgNO3 reacting, correct? Then how much will be the number of moles of NaCl reacting? For NaCl also same thing, number of moles is equal to the mass 2.9 divided by what is the molecular weight of NaCl? NaCl is 23 plus 35.5 which is 58.5. So you see how many moles is that. So if you take 8.45 divided by 169.8, that will be close to 0.0 0.05 moles. Similarly, we have 2.9 divided by 58.5. That is also equal to 0.05 moles. You see, we got the stoichiometry clearly here. What is the stoichiometry? Check out this. 1 mole of AgNO3 will react with 1 mole of NaCl to form how much AgCl? 1 mole of AgCl. So 0.05 mole will react with 0.05 mole to form how much AgCl? It will form 0.05 mole of AgCl. But what was the question? The question is, you need to find how much is the mass of the precipitate. You got the number of moles. How do you find the mass? Number of moles is equal to weight by molar mass. So the weight of AgCl formed is equal to number of moles into molar mass. Number of moles is 0.05 into the molar mass of AgCl, which is 107.8 and 35.5. Correct? 143.3. So 0.05 into 143.3. You don't need to exactly multiply, just approximate and see. You can take 140 into 0.05 will be around 7. Yeah, you have an option close to that. So option B will be the amount of AgCl formed, the precipitate formed. Is it clear? So that is the total mass of the precipitate formed. Okay, we'll do one more question here. 20 gram of magnesium carbonate decomposes on heating to give carbon dioxide and 8 gram of magnesium oxide. What will be the percentage purity of magnesium carbonate in the sample? See, here again there is a chemical change happening. So you need to write that particular chemical change. Magnesium carbonate, which is MgCO3, decomposes to form carbon dioxide and magnesium oxide. So MgO plus CO2. This is our equation, and it is already balanced, right? MgCO3 gives MgO plus CO2. What did they say? 20 gram magnesium carbonate decomposes to give carbon dioxide and 8 gram of magnesium oxide. So actually the stoichiometry which we need to analyze is between magnesium carbonate and magnesium oxide. So here we can write like this. MgCO3, this is 1 mole, MgO 1 mole, and carbon dioxide 1 mole. So in terms of mass, if you check, the total mass of MgCO3 1 mole will be how much? Magnesium is 24, 24 plus carbon is 12 and 48, right? 60 plus 24, that will be 84 gram magnesium carbonate is going to react with MgO. Mg is having, MgO is having a weight of 24 plus 16, that is 40 gram, and carbon dioxide is 44 gram. So this is our existing stoichiometry, right? Now, what did they say? 20 gram of magnesium carbonate decomposes on heating. It gave 8 gram magnesium oxide. So I will just note it down. The amount of magnesium oxide obtained on heating is, magnesium oxide obtained on heating is 8 gram. Okay, when 20 gram was heated. Okay, so I am going to check. If I take 20 gram magnesium carbonate, how much magnesium oxide am I going to obtain in real? How do I find that? Again, a very simple equation. You see, 84 gram magnesium carbonate is going to give you how much? 40 gram, correct, of magnesium oxide as per the stoichiometry. So the question is, 20 gram should give you how much? That will be 40 divided by 84 into 20, correct? 40 divided by 84 into 20. This is the amount of magnesium oxide which is supposed to come. So that will be 800 divided by 84, which comes around 9.52. This much gram of MgO is what is to come from this decomposition. But did you guys notice here how much was the magnesium oxide obtained? It is 8 gram. So I would call this as the actual yield of magnesium, and this is the theoretical yield of magnesium oxide. Correct? Now what did they ask? What is the percentage of purity? See, if it was 100% pure, you should have got 9.52 itself. So I can calculate the percentage purity as how much is the actual yield divided by how much is the theoretical yield you are expecting into 100. So that will be 8 divided by 9.52 into 100. Have you all understood what is the meaning of this theoretical yield and actual yield? When you do the experiment, how much you get in real, that's called actual yield. And according to the stoichiometry, how much you are supposed to get, that is called theoretical yield. So 8 divided by 9.52 into 100 is approximately 84%. So this sample is 84% pure. If it was 100% pure, the theoretical yield and the actual yield should match. You should get the same amount. Is that clear to everyone? Yes, Hafiz, very good. So that was based on the theoretical yield. See, I just want to conclude with one small question related to limiting reagent, because that is one portion which need to be thoroughly studied for the chapter Some Basic Concepts in Chemistry. So we will see one such question related to the limiting reagent. Okay, look here. 1 gram of magnesium is burned with 0.56 gram of oxygen in a closed vessel, and which reactant is left in excess and how much? This kind of questions is very common from some basic concepts related to limiting reagent. So here we have a chemical reaction. Mg plus O2 gives MgO. So magnesium is burned in oxygen and we need to balance this. 2 Mg plus O2 gives 2 MgO. So here, as per the stoichiometry, let's calculate the stoichiometric mass relationship. Okay, check out this. 2 Mg. 2 Mg means 2 into 24, that will be 48 gram of magnesium require O2. O2 means 32 gram to form how much? MgO's mass is 24 plus 16 is 40. 40 into 2 is 80. This is the stoichiometry that we have in terms of the mass, correct? The stoichiometry. Now, the given conditions, what is given in the question? That you see, 1 gram magnesium is burned with a 0.56 gram of O2. And they are asking which reactant is left in excess and how much. Let me remind you of the limiting reagent concept. What is a limiting reagent? A reagent which gets completely consumed in a chemical reaction is called as limiting reagent, and the remaining reagent is called as the excess reagent, correct? And limiting reagent is the one which is going to decide how much product has to be formed. So, how do I identify a limiting reagent? It's very easy. Look here, just look at the stoichiometry, okay, and then work it out based on that. See, what is the requirement of magnesium? 48 gram magnesium need 32 gram oxygen. This is the stoichiometry, correct? So tell me, 1 gram magnesium need how much? You need 32 divided by 48. Yes or no? I just wrote the stoichiometry here. That's it. No complication, nothing. I just wrote what is the stoichiometry. So this is equal to 0.67 gram oxygen. So I just found out 1 gram magnesium require how much oxygen to react. Okay. Now similarly I can think of the other way as well. I can think of in the other way as well, like oxygen and magnesium dependency. 32 gram oxygen need how much gram magnesium? 48. So given is 0.56 gram, correct? So I am writing 0.56 gram oxygen need 48 divided by 32 into 0.56. 48 divided by 32 into 0.56. This much is the amount, that is 0.84 is what is required. So did you notice what did I do here? I just found out for this much magnesium how much oxygen is needed, and similarly for this much oxygen how much magnesium is needed. Now things are very clear. Check out this. 1 gram magnesium is what is given in the question, correct? For that, stoichiometrically how much oxygen is required? 0.67 gram. But how much do I have here? I have only 0.56. That means there isn't enough oxygen to react with 1 gram of magnesium. So who is the limiting reagent? Who is the limiting reagent? The one who is getting consumed in the first place. Who will be that here? It will be definitely oxygen, because oxygen required is 0.67, but I have only 0.56 gram. So the limiting reagent is going to be oxygen. And did you notice the question is which reactant is left in excess and how much? They didn't ask you who is the limiting reagent, who is in excess. The other reagent will be in excess. Who is that? That will be magnesium. And how do we know that? Check out this. The amount of magnesium required for 0.56 gram of oxygen is how much? 0.84. But how much magnesium is given here? 1 gram is given. That means out of the 1 gram, 0.84 gram is going to react. The rest will remain excess. So how much is excess? 1 gram minus 0.84 gram. That will be 0.16. So the excess reagent is magnesium, and how much it will be excess is 0.16 gram. You see how easy is this when you break it down step by step. So magnesium is the limiting reagent and the excess reagent, and 0.16 gram is the amount which is in excess. Is that clear to everyone? So this limiting reagent related questions are very, very, very important. So always understand this limiting reagent is the one which gets consumed first, or it will be consumed completely in a chemical reaction. It is the one who is going to decide how much product should be formed. The remaining reagent is called as excess reagent, and that will be always present unreacted. And how to find the limiting reagent is just equate the stoichiometry. First you balance the equation and see the normal stoichiometry, like x gram requires y gram, so z gram requires how much. Like this you keep asking the stoichiometric relations to yourself, and then do it in your mind, and then do the small calculations in the rough part. And it is a very, very easy question, but majority of the students make a mistake when identifying the stoichiometric relationship. So I hope that part is clear to everyone. Okay, right. So let's have a very small quick quiz to check. So like we do every time, you have to take your phone and go to this website. And enter the code 33074825. The code is already pinned in the comment, so please look into the comment box for the instructions. Please join fast. We'll start the quiz now. Okay, so look into your screen. Question number 1. You can see the same question in your phone. Which has the maximum number of molecules among the following? So that was question number 1. Let's go to the next question. The crystalline salt Na2SO4.XH2O on heating loses 55.9% of its weight. The formula of the crystalline salt is? You can read the question in your screen. Twenty seconds remaining. Right. Let's see the leaderboard. Okay, so let's go to the third question. We have 3 more questions remaining. Right, on your phone. A compound possesses 8% sulfur by mass. The least molecular mass of the compound is? The least molecular mass of the compound is? Right. See, in that question, there is a small logic you need to remember. 8% is the mass percentage given, and they asked what is the minimum. So sulfur's mass is 32, right? So 8% means 8 in 100 grams. So in order to have a minimum 1 sulfur atom, you need at least 4 times more, isn't it? Right. Let's go to the next question, the fourth question. Yes, on your phone. What is the mass of carbon dioxide which contain the same number of molecules as are contained in 40 gram of oxygen? What is the mass of carbon dioxide which contain the same number of molecules as are contained in 40 gram of oxygen? Hint is both should contain the same number of molecules. Right, majority have got the correct answer. Excellent. Let's go to the last question. The last question. Which one of the following has maximum number of atoms? This should be easy. Right, majority have got the correct answer. So please remember that question was really important. I told you how we will determine who has maximum number of atoms without doing any calculation. You can answer this in fraction of seconds, 10 seconds or 5 seconds is enough to answer this particular question. So very good, let's look into the final leaderboard. Yes. So Abhin is leading in this. Very good, Abhin. Others who have made the mistakes, please clarify those doubts in the next class. We will be doing this module soon in the class. So that time please do clear these doubts and continue your hard work. Daily spend as much quality time as you can in reading NCERT textbook. Every line, every table, every data given in the NCERT textbook is important. And do not neglect anything from the textbook. those topics or portions which you think is not very significant will have definitely questions from that. So line by line, you have to read the textbook thoroughly. I hope everybody will be continuing these preparations, and we will have so many doctors, future doctors coming up this time as well. So we will see in the class with another topic. Until then, this is Danesh Venugopal signing off. Bye. Good night.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.